Hello everyone, welcome back to this new tutorial, and in this new tutorial we will study about relative frequency. Okay, so it's about relative frequency. Relative frequency is also called experimental frequency. So when you find in the exam paper is find the experimental frequency or find the relative frequency. So just do not get confused. It's the same thing. So what is experimental frequency? Experimental frequency is when you conduct an experiment, then the number of success you get out of the total number of trials. Number of trials. So this is called experimental frequency or relative frequency. For example, you flip a coin and and you do total 10 trials. 10 times you flip a trial and 6 times you get the head. So that is the probability of getting head in this coin is 6 out of 10 or 60% you can call it. 60% the result was had. So the experimental probability or relative frequency is like this. So you can plot this relative frequency on a graph paper as well, and in that you have to put on relative frequency here, your number of trials. So here trials on x-axis and on y-axis its relative frequency, and the relative frequency should be from 0 to 1, or you can in term of percentage you can call it 100%. Either you 1 2 3 4 5 6 7 8 9 10, so we can call this is 100%, or you can we can call this is 1 as well. Let me divide this whole area into 1 or 100% and 1 2 3 4 5. Here it will be 50% or 1 by 2, and it will be here 25%, 1 2 20 25. This will be our 25% region, and we can call it as 1 over 4, and 1 2, and this one will be 75% region, and this we can call it as 3 over 4, and these we can call just number of trials. 1 2 3 4 5 6 7, and so on and so on we can count, and then we can plot. We can conduct an experiment. In the first experiment, for example, our result was 1 out of 2. 1 out of 2 we can just plot here, and in the same way we can plot. So let's see an example from the textbook, and then see it how we can do that. So here is a book from which I'll just get an example, and the book is IGCSE book, and it's Unit 5, chapter handling of data, and it's 1. Yeah, so exercise is 1, and in this question it says Heidi believes that a particular die lands on the odd numbers more than the even numbers. So she carries out the trials. The results are given in this table. So the results is given in this table. This is a trial number from 1 to 10, and it landed on the odd number on these many times. Where there's a tick, where there's a cross, it did not land on an odd number. So you have to make a relative frequency as well. So the relative frequency for the first trial is 0. So 0 over 1, that makes it 0. For the second, it was a success. So the success over total number of trials. So the success was 1 and trials were 2. In the third was success. So total successes were 2 and trials were 3. In the fourth, it did not land. So the success remains the same 2. Successful outcome remains the 2 and trials have gone to 4. And here the success makes it 3, 3 over 5, and then it remains 3 over 6, and it goes to 4 over 7, and it remains 4 over 8, and it remains 5 over 9, and it remains 6 over 10. So this is the relative frequency. So we can just plot this relative frequency on the chart which we just studied. So let's make it smaller so that I can do it side by side as well. Okay, for the first experiment, we see that the success ratio was 0. For the second one, it was 1 by 2. So let's plot it here. Let me draw this with a different color. So for the second one, it was 1 by 2. So first was it was 0, so we do not just plot here. For the second one, it was here 1 by 2 or the 50%. And for the third one, it was 2 by 3. So 2 by 3 is 2 out of 3. So that makes around 66%. So for the third one, if this is 50, this is 60, and this is 70. So the 66 should be here somewhere. And for the fourth one, it was 2 by 4. 2 by 4 is 1 by 2. Again, for the fourth one, the probability comes back to 50%. And for the fifth trial, it is 3 by 5. So 3 by 5 is 6. 3 over 5 is 6 over 10. 6 over 10, you can call it as 60%. So this is 60%. And the seventh one was 4 out of 7. So 4 out of 7 is more than 50%, right? So 50% would be 3.5 out of 7. So 4 out of 7 is between 50 and 60. So up more than 50 and less than 60. So it would be somewhere here, the next trial. And the eighth one was again 4 by 8. That is 1 by 2. Again, it's 50%. And the ninth one was 5 out of 9. Or 5 out of 9 is again more than 50%, right? So it's more than 50%, maybe around between 50 and 60%. And the 10th one is 6 out of 10. So the 6 out of 10 is 60%, so it comes here. So if you connect these points, so it will be for the first one. So for the first experiment, it was 0. So you can just connect these lines. This you can call it as a relative frequency diagram. Relative frequency diagram. And for most, the final result here, this is 60%. Okay, 6 out of 10 or 60%, it landed on the, for 60%, it landed on odd number. So that shows that Heidi was hypothesis of the Heidi confirmed that for more than 50%, it is landing on an odd number. So landing on odd number is more than 50%, right? So the last experiment which we did here, so the last one, the 10th one, so the result of this, the last one is robust. So the more experiments you do, the result is robust. The initial result is not robust. So you should always consider the result of the last experiment, that what is the percentage or what is the relative frequency of an event happening. So the probability of odd number landing on the odd number is 6 times out of 10. So this should be very much the answer. Okay, so this was the question says draw a relative frequency diagram to investigate Hades' suspicion and what conclusions do these results lead to. So the results lead to the conclusion that 6 times out of 10, or the relative frequency or experimental frequency is 6 out of 10 for this experiment, that the die will land on odd number. And how could the experiment be improved, right? So the experiment can be improved if you do more number of trials. So the more number of trials are there, so more trials will make the experiment results more robust. So we go to the second question, and in the second question, it says that in the UK, April has a reputation of being a particularly wet month. So that means in April, uh, there's more likely to rain in the month of April. So for 20 days, the experiment was conducted, and the experiment conducted shows these results. So 10 and 20. Uh, Draw a relative frequency diagram to investigate the experimental probability of rain in 20 days. And what can you conclude from this data? So, what is the conclusion from this data? Okay, so what we can see do here is we can just count how many times it did rain out of these 20. Okay, so number one is we can make for each day. Like for the first one, it is 1 out of 1 relative frequency table. And for the first one, the result is 1. And for the second one, the success rate is it did not rain. So the success is still 1 and the trial is 2. For the third one, 1 over 3. For the fourth one, 2 out of 4. For the fifth one, 3 out of 5. For the sixth one, it's like 4 out of 6. For the seventh one, it remains 4 out of 7. For the eighth one, it remains 4 out of 8. For the ninth one, it increased to 5 out of 9, and for the 10 it increases to 6 out of 10. And I write the probability for 11 to 20 down here, and for the 11th experiment the success is still 6 out of 11, and for 12 it is 7 over 11. For 13th, it is 8 out of 13. For 14, it is 9 out of 14. Then 10 out of 15, 10 out of 16, and 10 out of 17, 11 out of 18, and 12 out of 19, and 12 out of 20. So the final overall probability of this experiment is 12 out of 20. So for every for all the 20 experiments, 12 times it rained, so it's more than 50%. The probability of raining, the results show that the probability is more than 50%. So if we have to draw, excuse me, a relative frequency diagram, so if we have to draw a relative frequency diagram in the same way as we draw before, we can draw a relative frequency diagram here for this experiment as well. Let me erase whatever I did before. Okay, so now we can draw. For the first one, the result was 100%. So for the first trial, we can draw it as 100%. It was here, and for the second it was 50%. So 50% is here, so for the second one it's 50%. For the third one it's 1 over 3, so 1 over 3 is around 33%. So for the third one, if this line is 30, this line is 40, right? So it should be 33% should be here. Okay, and the next line, the fourth one, the fourth experiment, it was 2 out of 4. 2 out of 4 is 1 by 2, that's again 50%. That's again 50%. And for this next experiment, it's 3 out of 5, and next experiment it's 3 out of 5. So 3 out of 5 is 6 out of 10. So 6 out of 10 is 60%. So this line is 60% here. And for the next one, it is 4 out of 6. 4 over 6 is 2 out of 3. 2 out of 3 is 66%. So the 66%, if this is 60 line, this is 70 line, so the 66% should be somewhere here. So in the same way, you can just plot your, by plotting, after plotting all the data points, you can just connect the lines and show a diagram here. Okay, so this is how we can plot it here. So the final probability is you have to plot for all these values, right? So I'm just leaving it to save the time. And what can you conclude from this data? What we can conclude? So out of 20 times, out of 12 times out of 20, the probability of rain was there. So that shows that more than 50%, more than 50%, right? So there was rain. And if we take this out of 30 days, so for more than 15 days, more than 15 days, it should rain. So 12 out of 20 was 12 out of 20 times if the days are total 30. So if you want to just calculate that for how many days, it's likely to. So this cancels out. This 6 3s are 18. So we this probability shows that for 18 days in April, it's likely to rain. It's likely to rain based on this experiment. So the next question says that a spinner for a word game is an irregular pentagon has 5 sections, right? So there are 5 sections in it: A, B, C, D, E, and Sanjeev is keen player and he wants to experiment to see if he can do it by probability of landing on a vowel, that how many times it lands on the vowel. The vowels in the spinner are A and E. The results are shown. So here are the results, right? So we should just first find results, and we the question is draw a relative frequency diagram. So for drawing the relative frequency diagram, the procedure is the same, in which we do right for the first experiment it is the 1, for the second is also the result is 1, for the third one, so 2 out of 3, 2 times out of 3 it is success, for the fourth ones 2 out of 4 times success, for the fifth ones uh, 2 out of 5 is success. In the same way for all these 20 experiments, and then draw a frequency diagram the way we did it before the previous exercises, and then investigate the experimental probability of the spinner landing on the vowel. So now, if we see for all these 20 experiments, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 20, the experimental probability of vowel is 9 out of 20. Okay, so where is what should be the probability of theoretical probability? So the experimental probability is this one. So the theoretical probability of vowel should be there are two vowels out of total five. There are five alphabets, so 2 out of 5 are vowels. So if we take it out of based on this experiment, the conduct, right? So 2 out of 5, and it should be its probability and times 20. If we do 20 times, so 5 fours are 20, 4 twos are 8. So 8 times it should land. The theoretical probability says that 8 times it should land on the vowels, whereas actually it is landing 9 times, right? So 8 out of 20 times it should land theoretically. So the theoretical results shows 8 out of time it should land, whereas practically it has landed 9 out of 20. So that shows that they are pretty close, and the experimental and theoretical probability both are the same. Okay, so this is the theoretical probability, and we go to the next exercise, and in the next exercise it says that Pyre is a basketball shooter and he practices hard to improve his particular skills. He makes 12 attempts from the left hand side and 12 attempts from the right hand side, and the result are here for his result of left hand side. So what is the relative experimental probability, right? So the question says that draw a relative frequency diagram to estimate probability of left, right, successful in left and probability of success in right. What advice would you give to Perry based on this evidence? So if we calculate the probability of left, and how many times it is success divided by total outcomes. 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 12 he is successful. In other words, 2 out of 3, or 60% or 66% he is successful. Whereas on the right side, how many times he succeed? 1, 2, 3, 4. So probability of right side scoring on that basketball court is 1, 2, 3, 4. 4 out of 12 or 1 out of 3, or 33%. So on the right side, the probability is that 1 out of 3, or the 33% is the probability that he will score, and on the left side he will score 66% is the probability. So you can just draw a diagram based on this the same data which we did before, by first calculating for each of the value and then drawing. So the result shows that uh, what advice you would give. So I would give him the advice to play on the right left side, because he has got more probability to succeed here. And the next question here is that the table shows the results of rolling a six-sided die. So here is a die which has a six sides, and the numbers are written from 1 to 6. So for example, if you imagine there is a die here, and the die has, of course, this kind of shape. Probably my drawing is not very good, but still we can imagine this one is 6, this one is 5, this one is 1, this other side is 2, below 5 is 3, and opposite 6 is 4 there. So this kind of uh, a die is here, and when it is rolled 23 times, the number outcome is 1. 22 times it lands on 2, and 21 times the result is 3. In the same way, for 7 times the result is 6. So if we count these all, total number of frequency is 100 times. So when 100 times the experiment is conducted, uh, we can see that 6, the 6, number 6, the result of number 6 is 7 times. Okay, for all others this one. So copy and complete the table calculating the relative frequency for each outcome. For the outcome of number 1, it is 23 out of 100, and for 2 it's 22 out of 100, for 3 it's 21 out of 100, for 4 it's 18 out of 100, and for 5 it's 9 out of 100, and for 6 it's 7 out of 100. So what is the experimental probability of rolling a 6? So rolling a 6, the experimental probability is 7 out of 100, right? So if you do it 100 times, you are likely to get 7 times rolling it on 6. And when the die is rolled 500 times, how many times would you expect to get a 6? So in 100 times, if you get right 7 times, so for 500 times you have to time it with the 5 on both sides, so you will get 7 fives are 35 over 500. So 35 out of 500, you will get 6. So that means for 35 times you get this one. And is it a fair dice? Give a reason for your answer. So if it was a fair dice, the probability of rolling on a 6 would be 1 out of 6, right? So 1 out of 6 makes around 6 16, yeah. So if you do 100 times 16, you time both sides with the 16. So 16 6 around 100, right? 16.6 or 16.6 divided by 100. So this shows that if it was a fair dice, uh, around 16 times it should come one, the six, number six. So whereas only 7 times it rolled on six. So that means that the dice is not fair. It's a not fair dice because there is a huge gap. So theoretically, it should land 16 times on 6. So if it was on 17 times, 15 times, around 16, it was fine, but it did not. So that shows that the dice is not very fair. A bag contains 100 marbles. Uh, and of similar size, the marbles are either white or purple. The number is not known, so we do not know that how many marbles out of these 100 are white or purple. And marble is randomly taken from the bag and replaced before another is taken out. So 20 marbles are chosen in this way. So the result is here. So we conducted the total number of trials for 20 times. And out of these trials, how many times we got white? So probability of white is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times out of 20, it is probability of white, whereas the probability of purple is 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 20 is probability is uh, purple. Even W is defined as a white marble, P is purple, so use these values to estimate the probability of white and probability of purple. Comment on your findings. Estimate how many marbles of each color are in the bag. So on this, keeping in view of these probabilities. So the probability of white is if 20, then we can calculate that out of 100, how many are likely to be white. So probability of white total, we can calculate 12 over 20 times 100. So there are total 100 marbles. So this cancel out with a 5. 25s are 100 and the 12 fives are 60. So there is likely to be 60 marbles of white color, and probability of purple is like to be 8 out of 20 times 100, and that gives us 40 marbles. So 40 marbles are likely to be purple and white marbles are likely to be white in this experiment.